Good morning, and today we're going to be looking at closed intervals. And to do that, sometimes we have to restrict a part of the graph and just look at an interval within the restricted domain within the graph. Okay, so here we have a graph given. What we're actually going to be looking at specifically is what the highest and the lowest values are of the graph. But if I was just to ask you for that graph there, what would be the maximum value and what would be the minimum value on that particular graph, then you would quite rightly say positive infinity for the maximum value, because it would just keep going up and up and up, or negative infinity for the lowest part of the graph. So because that would be the answer to the maximum or the minimum on that graph, then we have to restrict the domain. So if we want to just look at a little window for that graph between x equals -1 and 7, then here we have just a little part of the graph that we want to restrict. So here's -1 and here's 7. So it's a different answer now when I say, well, what's the maximum and what's the minimum on the graph just between -1 and 7. So if you actually look at it here, we're just looking at this part of the graph here. Okay, we can see it shaded in there. So if we want to know what the maximum or the minimum value is, we really want to know what's the highest point, what's the lowest point on the graph. So what we have to do here then is we have to consider what's the y value of the outside points here, okay, at the actual outside of the interval. And then what would be the turning points on the graph? And then compare all the y values to see which part of it would be the highest. Okay, because that's why we've got to look at the closed interval that's given. Now we can see we have a point on the graph there at the outside. Then we have a point in the graph at the turning point there. Then we have it noted on that turning point. We have it noted there. So we want to know what's the highest point and what's the lowest point. That's what we mean when we say what's the maximum and what's the minimum. So we can see that the maximum here is actually this point here, and the lowest is this point here. So we have to consider all the turning points plus all the outside points as well. That would be the highest point. That would be the lowest point. Okay, there we can see it there. Okay, right, so the maximum and the minimum values of a function can either be at the turning points, which we call the stationary points, or at the end points of a closed interval. Now that's just to explain how we do this, so let me show you with an example. Okay, so a function f is defined for x between -1 and 4 by f of x equals 2x cubed minus 5x squared minus 4x plus 1. And we're asked find the maximum and minimum value of this function. And obviously we mean between -1 and 4. Okay, because if we don't, then the maximum and the minimum would just be positive infinity or negative infinity. Okay, so f of x is equal to, okay, so we make f dashed of x equal to 6x squared minus 10x minus 4. And we're just going to treat this like a stationary points question to begin with. So the stationary points exist where f dashed of x is equal to 0. So we make 6x squared minus 10x minus 4 equals 0. Take out common factors if we can. So we've got a factor of 2 that can come out there. Makes it easier to factorise when you take out a common factor as well, okay? So it's important to try to remember to do that. So we've got 3x and an x, and we'll have a 1 and a 2 for the factors of the last term. Now that leads to x minus 2 and 3x plus 1, which leads to x minus 2 being equal to 0, or 3x plus 1 being equal to 0, so x is equal to 2, or take the 1 over, make it a minus 1, take the 3 over, make it divide by 3, x is equal to -1/3. So we've worked out that this is where the stationary points occur, so the graph starts to turn at these points, okay? But the reason that we had to find that out is because we want to know what the corresponding y values are for those points. So the y coordinates of the stationary points when x is equal to 2 and x is equal to -1/3. So let's find what the y values are. So we put the 2's in, and we get for x equals 2, the y value would be -11. Okay, and then we're going to do the same with the -1/3, and again, a more awkward number, so just try to be very careful. So we're going to put the negative 1/3 in. I would do this in stages, work out with negative 1/3. So that would be a 1 cubed over a 3 cubed, which is leading to your negative 1/27. Remember, that's 2 times that, 5 times that, okay? Put it all in, work out what we have. So we've got a negative 2/27, a negative 5/9, a negative 4, a positive 4/3, negative times a negative, and a 1. Okay, and then we can tidy that up with a common denominator. Now, obviously, if you're able to use a calculator, then still do these in parts. If you try and put all that in one go, you're unlikely to get the correct answer. So still do all these in parts. If anything, that could go into the calculator in one go. If you're doing it without a calculator, obviously you need to get common denominators. So we've got stationary points is at 2, negative 11, and what negative 1/3, 46/27. Okay, so that's just short of 2 there for that y value. Okay. So we find the points at the ends of the closed interval. So the closed interval is given as between negative 1 and 4. So we're going to now put f of negative 1 into the f function and see what the y value is for that. So that y value turns out to be negative 2. And let's put 4 into it as well. So these are all going into the f functions to see what the y's are, to see what the heights are. So let's see what y is when we find out f of 4. So it's 128 minus 80 minus 16 plus 1, which is 33. So that gives us the coordinate 4 and 33. So we've got our coordinates of our stationary points, we've got our coordinates of our outside points, our extremities. So the stationary points we're given as 2, negative 11, and then negative 1/3 and 46/27. The outside points are negative 1 and negative 2, and 4 and 33. And then to work out what the maximum and the minimum values are, we're now just going to be comparing all of the y's. So there we've got a y there, a y there. Now 54/27 would be the whole number 2, so that's just short of the whole number 2. There we've got a negative 2 and we've got a 33. So we're comparing all of the y. So what's the biggest y value? The biggest y value is the 33. And there's a negative 2, that's a positive, negative 11. So the lowest y value is negative 11. So the maximum value is 33, and that occurs at x equals 4. And the minimum value is negative 11, and that occurs when x is equal to 2. So we're just comparing all of the y's. So we use differentiation to find the turning points. We don't need to even know what the nature of the turning points are, so we don't need to bother with nature tables. We just want to know what the y's are. But we also want to find out what the y's of the outside points are as well. And those x's are given in the question. So you're putting each of these x's into the equation to get the corresponding y's. And when you've worked out your stationary points, you're putting those x's into your equation to get your corresponding y's. And then you're picking your highest y value and your lowest y value. That's how you would do that. This is what it looks like in the graph. You wouldn't be expected to take it this step further. This is what the graph looks like. Okay, and we can see here that the 33 is indeed the highest point, and the negative 11 is the lowest point there. That's what we've got here. Highest and the lowest points in the graph. Okay, and that's us finished. So do the questions listed. Take care and good luck.